All right, so number one, the object below is sliding to the right with a velocity of 10 meters per second. Given that the force of friction acting on the object is 15 newtons, what is the acceleration of the object? So we need to make sure we have all of our forces. We have the normal force up from the ground. Gravity always pulls things straight down. And friction is trying to make this thing stop sliding. Some people often want to put an arrow over here on the right, but we're not going to do that. There's no one pushing this thing. It's just sliding and coming to a stop. If it was pushed before we looked at it. We don't care. Numbers that were given in the problem, we know that friction is 15 newtons. The mass was given at 5 kilograms, and we're trying to find A, the acceleration. So now we're going to go and look at left-right because it's going to accelerate to the left because it's slowing down. The only force acting on it left-right is friction. That's the way it's going to accelerate. So I set up my equation. I have friction in the negative direction because it's to the left. I don't have any arrows to the right, so I'm not going to make one up. There's just only one force, and it's negative friction. That's going to equal ma because all of my forces going left and right added up, and there's only one of them, equals ma. That's Newton's second law. All the forces equal mass times acceleration. I'm trying to solve for acceleration, so I do a little bit of algebra. I divide by the mass, bring it over to the left side, so I have negative friction divided by the mass equals acceleration. And I can plug in my numbers. I know that the force of friction is 15 newtons. That was given in the problem. It is still negative because it goes in the negative direction. The mass is 5 kilograms. 15 divided by 5 gives me 3, and it's still negative. That negative 15 makes it all negative. And it's negative 3 meters per second squared for the acceleration. Moving on to number 2. In number 2, you're pushing an object to the right with a force of 20 newtons. That's my force of push, 20 newtons. That's why it's right here. There's a frictional force opposing you that is 12 newtons. That's also given. What is the acceleration of the object? Always a good idea to write down the stuff you're given and what you're trying to find. Again, this thing is going to be accelerating in the left-right direction. So I'm going to set up my equation for my left-right direction, which is force of push because it's to the right, minus force of friction to the left equals ma. Because all my forces added up equal mass times acceleration. Again, we're trying to solve for acceleration, so we just divide by mass. So force of push minus friction divided by mass equals A. I can plug in my numbers. Force of push is 20, friction is 12, mass was 9. Plug that into my calculator. I get 8 divided by 9, which is 0.89 meters per second squared. It's positive. It's going to be to the right. It's going to be in the way that you're pushing because you're pushing 20 and friction is 12. It's more to the right, so acceleration is going to be to the right. Now, number 3. In this problem, a 20 kilogram mass is allowed to accelerate down a frictionless ramp. So there's no friction going in that direction. It says very clearly it's frictionless. So what forces do we have acting on this? We have the normal force in the upward direction, gravity perpendicular in the downward direction, and gravity parallel going down and to the right on the hill. Trying to find the acceleration, that is part A. What is the acceleration of the block down the ramp? Well, gravity parallel is my only force acting on this going left and right, so that's going to equal ma. Divide by the mass. To algebraically solve for A, gravity parallel over mass equals A. Now I just have to plug in what is gravity parallel. It's on your equation sheet and on the board in the class. It is the sine of the angle. The angle is given in the problem at 15 degrees. So it's a sine of 15 degrees times the mass, which is 20, times 9.8 meters per second squared. And then we divide by our mass, as we did over here. Just have to plug in our numbers. 20 kilograms. You might notice that 20 kilograms in the top and 20 kilograms in the bottom actually cancel. It doesn't matter if this thing is 20 kilograms or 10 kilograms or 1,000 kilograms. The mass is always going to cancel. It actually doesn't matter what the mass is. When there's no friction, it's going to slide down this ramp with the same acceleration no matter what. And that's going to be 2.54 meters per second squared. Part B. We're going to assume the block starts from rest, and how long is it going to take it to slide a total of 30 meters if it's a 30-meter long hill? Well, for that, we're actually going to go back to kinematics, a little bit of review. Our 5 things that we know, the D is 30, because it's given in the problem how long it's going to take to go 30 meters, and it's starting from rest, so V naught is 0. We just solved for acceleration of 2.54 meters per second squared, and the question says, well, how long is that going to take? So I pick my equation that does not have VF in it because that's the thing we don't have and don't care about. So I'm going to use D equals V naught T plus 1/2 AT squared. V naught is 0, so I can cancel this term out because V naught being 0, 0 times anything is 0, so it just goes away. And that leaves me with D equals 1/2 AT squared. A little bit of algebra to solve for time. I move the 1/2 over, it becomes a 2 in the top. I divide by a, that's where it's in the bottom. And to get rid of my squared, I take the square root. Plugging in my numbers, I get 2 times 30 in the top over 2.54 meters per second squared in the bottom. Take the square root, and I get 4.86 seconds for this thing to slide a total of 30 meters.